Hello everyone, and welcome to today's presentation sponsored by Seal Aftermarket Products, as well as our co-sponsors Toledo Transkit and Whatever It Takes.
Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Okay, if we have any questions or comments, please send your emails to webinars@atra.com. If you have any questions during the webinar, please feel free to text them to me, and I will answer those as best that I can. I'd like to mention our webinar schedule. The next webinar will be on April 21st and 22nd. It will be on the rebuild of the CFT30. Also like to mention, Expo this year will be on October 29th all through to November 1st. It will be in Las Vegas at the Rio, same place we had it last year. If you guys have never been to Vegas, this is Halloween weekend, one of the best times to be there. Here's our schedule throughout the year for our seminars across the country. The next one we'll have will be actually this weekend, April 11th, in Minneapolis. Today's presentation will be talking about the introduction to the GM 8L90. This is brand new for this year. It's just coming out as a standard equipment in the 2015 Corvettes. Available in the Corvette is standard equipment, but an upgrade in some of the SUVs. Shortly after, it will become a standard equipment across the board for all the SUVs, trucks, and the Corvette. Right now, from what I understand, if you want the transmission in a Yukon Denali, that would be considered an upgrade. Some Silverado double cabs with the L86 engine will come standard with that transmission. Otherwise, you'll still have the 6L80 that we've been dealing with in the past. The RPO code for this unit is M5U. This is a fully automatic 8-speed. The 6-speed again still will be standard option. It has 4 planetary gear sets in this transmission, 2 brake clutches and 3 rotating clutches. Now the 3 rotating clutches have been located forward of the gear sets. They're up in front of the planetaries. This was to minimize the length of oil feeds to the actual clutches to enhance the shift response. There's also a chain-driven fluid pump, very similar to the ZF8. Okay, there will be different variations of this transmission based on torque capacity. Obviously, the components internally will be common, but there'll be differences in size and also in clutch capacity. The bell housing and case are all one piece. There's no separation of the bell housing like we've seen on the 4L60Es. We mentioned already there is an off-axis chain-driven pump. It's a binary Vane type pump. It's like having 2 pumps in one. It's got a lot less parasitic loss of oil, and it has a real quick priming capability, which provides enough oil routing through the control system for the amount of volume and speed that we're going to need that oil to come up. It's actually located on the valve body itself. The TCM is externally mounted. We no longer have to deal with the TCM being on the valve body. And the TCM uses 3 speed sensors to control the shift response and accuracy of the shifts. Now, as far as the pump goes, at low speeds, they're both the ports that supply pressure fluid to the transmission will be able to provide oil at low RPMs. At higher speeds, when we don't need that much oil pressure, it'll actually go to one discharge port. It does have two imports. Suction side will reduce it when it doesn't need the two outputs. It'll go to one. The other output will actually go back to the suction side of the pump. Now, this pump will work a lot quicker, and it'll adjust to demands a lot faster than a slide on a variable displacement pump like we have with the 4060Es and the 4080s. This is where the pump is located. You can see it's right there in the bottom right of the valve body. We actually removed it, and you can see the internal parts of it. A little bit about the case. As you can see, the one on the left is obviously for a Corvette. That'll bolt directly up to the differential. There'll be a torque tube from the engine down to the torque converter. And obviously the one on the right is for an SUV with two-wheel drive or a truck. There is also four-wheel drive versions available. And you can see the coolant lines are right there in front of the linkage shaft. And I want to talk a little bit about those. You'll see that there's two closed seals in each one of the coolant line ports. Now, what you might want to do is warn your installer or your builder not to just pry those out of there. You could damage the case doing that with a screwdriver. We used a blind hole bushing remover, and we put that on a slide hammer, and we easily pop those seals out without causing any damage to the case. This is a little closer look at the seals. As you can see, they're closed off. When you press the coolant lines into the seals, it'll actually break it open right there where you see those lines, and then we'll have a good seal around the coolant line without having any leaks. Okay, the TCM is going to monitor different load sensors on the vehicle as well as the speed sensors to control the shifts. There's 5 multiple discs, we mentioned already, 3 driving and actually 2 brake discs. There's only 1 reverse gear ratio, unlike when you would find on Mercedes it has 2 different ratios in reverse. Now the 4 gear sets, or the 4 planetaries that we're talking about, is the direct overdrive gear set, the input gear, reaction gear, and output gear set, and we'll show you those in a bit. Now the 5 clutches are actually named for what they do. So we have a 1, 3, 5, 6, 7 clutch. That's when that clutch will actually be applied during those shifts. Here's a cutaway view to give you an idea of the layout of the transmission. As you can see, all 4 of our planets are towards the rear. 2 brake clutches are also in the back of the transmission. And you can see that the 3 driving clutches that I have in the red square, those are in front of the planetaries. Again, that was for a quicker fill time. This is the solenoid identification. Same thing with the solenoids. You'll notice that they're all named for exactly what they're going to control. So the solenoid is named for each clutch that it's going to control. Now this default control solenoid that you see in the middle left side of the valve body, at first when we were studying this transmission, we thought this was definitely going to be for fail-safe, but it actually has more than one function, so it's not just a fail-safe solenoid. Later on in different articles and seminar pieces, you'll see we'll go over some of the hydraulics on how this transmission works. Here's your solenoid identification. I wrote an article in the January-February Gears magazine explaining how these pun and ton numbers work. Basically what you have is a part unique number located on the valve body and the solenoids. And then the transmission has a unique number also located on the case, which they refer to as the ton number. Now, these part numbers identify the solenoid performance characteristics as far as their flow rate and whether they're normally high or normally low. Now, all that information is stored in the TCM, and this is also part of the TIS2Web website with the service programming system. Now, if you change the valve body or the solenoids or anything like that, like TCM during any repair, you're going to have to go to the website and reprogram the TCM to the new strategy numbers that come with the solenoids that you're replacing. Here's where the pun numbers are located. As you can see, the ones on the solenoids to the right. Now, each solenoid looks identical, but you'll notice that there's a different pun number on each solenoid. And that those numbers have to match the pun number that's on the valve body. And as you can see on the bottom, that's the ton number or the transmission unique number right there on the case. Now, all these numbers are programmed to the TCM, so any changes there would have to be reflashed into the TCM. This is very similar to what we're seeing on the 6R140. We've covered this in past seminars. I'm seeing more and more of it. If you change the solenoids on a 6F50, you have to take the solenoid strategy number and also program that to the TCM on some of the Fords. So this is going to be a common practice across the board eventually. All the solenoids, the PWM solenoids, have the same resistance, even though the pun numbers will identify what the solenoid actually does as far as if it's normally low or normally high and what the flow rate would be. The two on and off solenoids, there's no difference between them. The part numbers are the same. You can swap those around without any problems. Now this is the solenoid and clutch application chart. What I want to point out here is this is not an electrical chart for the solenoids. This is actually a solenoid working apply chart, not a voltage apply. And what I mean here is this is very similar to what ZF has done in the past. When I first started studying ZF hydraulics and solenoid apply, most of the charts that we got were in German. And we found that the word on, what they were using was the word working. So think of the word on as working and off as not working. Let's take reverse for an example. All these solenoids that we see here are all fed amperage. These are PWM solenoids or pressure control. Now in reverse we have 1, 2, 3, 4 solenoids that have to be activated or working to apply 1, 2, 3 clutches. We have 3 clutches being applied in reverse, as well as 4 solenoids to work those clutches. Now if you take the word on and you think of that as amperage or voltage, this is a normally high solenoid. Being that if the solenoid was off, we would have pressure. So if we're actually applying voltage to it or amperage, the pressure would be low here. So basically this word means that it's working. If you were to actually check this solenoid for amperage, you'd probably find that it would be very low, if any amperage at all going to it. Same thing with this one. This is a normally high solenoid. Now this one's normally low. So obviously if we turn it on, we are controlling it, so it is working also. Same thing with the on and off solenoid. Basically if you look at the hydraulics, you'll see that the solenoid is working at that point. Now fail-safe on this transmission is 6 gear. It's a 1-to-1. One of the other things that I was surprised about when I started getting involved with this transmission was no sprag assembly. There's no sprag in this transmission. Now when the ZF6 came out and the 6R60 used in the Ford, they did not have sprags in those, and we always seem to have a lot of problems with downshift complaints, especially on the 2.1. Now when the 6L80 came out at the same time, they always had a sprag in the GM. Even though it was the same technology, they did use a sprag on those, and we didn't seem to have as many complaints on the coast down. So I was a little surprised to see they're not going to have one in this transmission. Here's some of the general specifications. You can see some of the gear ratios that we have here on the right. We also have the torque converter size, and this takes Dextron HP. Now the HP does not stand for high priced. Just kidding, guys. I wouldn't be surprised if the price is high. I don't know what the cost is at this point, but being brand new fluid, I'm sure it's not going to be very cheap. Transmission weighs about 210 pounds. Okay, let's talk a little bit about service fast learn or fast learn procedure. The procedure is performed after any of the any transmission repair has been done. I mean, even if I did a service on this transmission, I would probably want to run it through the fast learn just in case there was any air pockets or anything in the transmission that could cause any problems. Obviously, any repairs we do, even if we just went through the valve body or anything like that, we're going to have to perform the fast learn. Now, the fast learn is a series of tests for the TCM to learn the individual clutch applies. Now, these values are used by the TCM to control the timing and actually the clutch feel. A scan tool is going to need to be used here, so we're going to need a scan tool that's capable of doing this. Obviously, if we don't have one, we'd actually have to take it over to the dealer. And you can see some of the repairs we're talking about. Even if you just replaced the pressure regulator solenoid, you'd have to do a fast learn on it. Any valve body repair, any repair that has anything to do with shift quality concerns. Obviously, if we change clutches, clearance is going to be a little bit different, so we're going to have to do the fast learn on the transmission. Now there's also shift adapt. This is after we've done our fast learn and we have to take the vehicle out and actually drive it and get it to relearn or readapt the shifts. Now the TCM is going to monitor the input speed sensor, the intermediate and output speed sensor to control the shift commands. If the shifts are happening too fast or too slow, obviously the computer is going to control the PC solenoid to get that shift field set to the correct settings. Now we're going to take you through a series of tests that you'll have to do. You need to follow these step by step, and you'll find these on the following pages. Now, one you're going to find on this transmission, if you're just driving it normal, coming to a stop, you'll notice that it doesn't go 3-2-1. It will actually coast down to a 3-1 shift. That's considered normal. Now, here what I'm showing you, the apply clutch and release clutch are learning these clutches, the actual shift field that would correct these clutches. Notice that they've named them C3, C4, C1, C3, so this got a little confusing to me, and you'll notice on your handout material on your apply chart, I did list those identification letters and numbers above each of the clutch packs. So if you go here, you'll see that to learn the C1 clutch, the C1 clutch is actually the 1-2-7-8 reverse clutch. We give you the procedure to follow through to relearn that clutch. Then you'd also have the C2 just below it. And on this slide, you'll have the C3, C4, and we identify the clutch that matches those. One of the things I do want to mention here, you notice like here on the C5 relearn, the bottom paragraph says repeat this a few times and retry to feel any shift complaints. So it doesn't have an actual set amount of times to do this. So you may have to do it more than a few times. You may have to do it 10 or 20 times so you get that shift field to feel right. And that chart will show you what shifts that will actually relearn the clutches. Now just below that we have the coast down shift adapt. This is obviously not a passing gear type drive. This is just an actual coast down. Now notice here it says right away repeat 10 times. So we know that we have to do a minimum of 10 times. So this is not going to be a 10 or 15-minute road test. Your technician may be out on the road for quite a bit to get these to relearn the adapts for the clutches. Here's the power downshifts or kick downs or passing gears. Notice here it says repeat as necessary in each gear. Then we also have the garage shift adapts. This is obviously for engagements. And you'll notice this one will say repeat as necessary until desired shift quality is achieved. So we may only have to do it 2 or 3 times, but we may have to do it more than 10. So just be aware that when it says to do it until necessary, it depends on how quick it's learning. Here's your 3 speed sensors. You can see they're on one harness. So if you need one of them, you have to buy all 3, but it is separate from the main harness. What they keep mentioning out through GM's factory manuals and training manuals is these torque-to-yield bolts. These are a very lightweight bolt. If you had about 10 of them in your hand, you probably wouldn't even feel the weight. They break very easily. They're supposed to be used once. So when we take them out on a rebuild, we're supposed to throw them away and use new ones. Now, obviously, in the real world, like you and I, we'll just probably reuse them if they're not broke, especially if it's just holding down a bracket for a speed sensor or anything else that's not really under any type of pressure or needs to be torqued. Do not take these bolts out with any air tools. I can tell you that right now. You'll end up breaking probably half of them, if not all of them. You're supposed to break them loose first with a hand tool. Okay, this is where the sensors are actually located in the case. As you can see in the top middle section is where the speed sensors hook up to the main harness. In the upper left corner of the case, you'll see the harness, the main harness that comes in. That's the plug that would go to the harness for all the solenoids, the temp sensor, as well as the internal mode switch that you see at the bottom of the case. And there's your torque-to-yield bolts. Now, when I took the valve body off this unit, this was the only seal that we saw between the valve body and the case. So make sure that this doesn't get lost or gets replaced during every rebuild. Now, to get to the pump assembly, we're going to have to first take off this fluid baffle. And this is going to expose the sprocket and chain so we can remove that to get the valve body off. Now, you'll see that these are also torque-to-yield bolts. According to the factory, these bolts are torqued to their maximum stretch, and then they're turned another 90-degree angle. So these bolts are basically maxed out, so it's not going to take much to break them. The same torque plus socket we used on the 6-speed can also be used on this unit. Now, this was the actual baffle that we were taking off at Seal Aftermarket Products where I was working with this vehicle. We noticed a missing torque-to-yield bolt. Now, the factory recommends, as you can see here on the right, to take a punch that fits inside the head of the bolt and lightly tap it. We just want to kind of break the tension free on it. Then we went in with a speed handle, as you can see in the bottom left, and we took the bolt out by hand. We did not have a problem with it, but you can see on the right, someone else had tried to take it off with an air tool and obviously broke the bolt off into the pump. Now, this is the drive sprocket and chain. This is over by the bell housing area. We found that the drive gear that actually goes onto the hub of the converter, the dimensions were the same on both sides of the gear, so you could actually flip this gear around. It really wouldn't matter. There's also a thrust washer, as you can see here, that goes between the bell housing and the gear. Now, when we go to remove the one on the pump itself, you're going to find that as soon as you grab the gear before you even pull on the locking tab, you're going to find the gear is very, very loose. It'll seem abnormally loose. That's actually okay. That's the way it's done. It's made. This was an actual 2013 model that we were working on. This was right from the engineers. So we found that the transmission was having issues with the chain breaking. Now, they originally had that sprocket on that shaft pretty steady. It didn't move at all. And they had some issues when the RPMs would pick up where the chain would load from side to side from vibration, and it was actually breaking the chain. So they decided to go ahead and still lock it to the shaft so it can't move forward or backwards. But even though it's locked to the shaft, it's still pretty loose. So that now at higher RPMs, the sprocket can actually center itself and there's no side stress on the chain. So now you can take a scribe like you see here. We're just going to reach in and grab that tab. You're going to pull it out of the slot and then pull it up. Once you remove it, it'll look like this. And you can see that the opening of that tab is a lot smaller, where it's going to go around the groove on the shaft to hold it in place. When we go back in with it, obviously we're going to line that tab up with the groove, and then we just slide it down until it clicks into place. If you don't have it in the right spot, that tab will not slide down far enough to actually even, it won't even be able to barely move, and you won't be able to lock it in place. You just have to move the gear to the slot for that locking tab. A little bit more look at the pump here. We can see that there's a gasket and a seal. These are not to be reused. And what you see here on the right is a sleeve that's supposed to go into the pump, and that direction is a tab that sticks out on the right, and that's supposed to go down inside the bore first. Now this sleeve is supposed to be there to prevent any kind of cavitation in the pump. Now the one that we worked on did not have the sleeve. I don't know if the engineers that were working with it just left it out, or you may not see it on some models. A little close look at this seal. When we put the seal back in, or we put a new seal in this pump, make sure you line it up correctly. I can see this mistake possibly being made, and we wouldn't want to have any issues with any kind of cross leaks here. The internal mode switch, nothing new. We've seen internal mode switches before. There is something a little bit different about this one. The common thing that we've always seen, it's got one switch that controls the starting of the vehicle and park and neutral. And then we have 5 other switches that are actually Hall effect switches to let the TCM know what gear has been selected. To remove the switch from the transmission, you'll have to take this roll pin out and then remove the linkage shaft. It'll all come out in one piece, as you see there. And then we can remove the linkage rod and spring, and also the park rod. One thing I do want to warn you about, obviously this is the first one that we worked on. When we tried to remove the plug from the connection there to the IMS, we lifted up on that little white tab. Now the tab did lift up, but the plug still didn't want to come out. So we kind of messed around with it and actually ended up forcing it off, only to find that when you lift up the tab first, then you have to go in with a scribe or some tool and press in on the area that you see on the right. If you don't do that, you'll end up breaking the tab off the end, as you see here, because that's what we actually did. So you might want to be careful taking this plug out. Now, the scan tool data that you're going to find on the capable scan tool when you're diagnosing one of these, you'll see that there's 5 Hall effect switches. They're actually fed 9 volts to each one. Now what's really odd here is what the signal is supposed to look like to the TCM. It's not looking for a 0 or 9, it's looking for something in between. As you can see, it's a real low voltage. It's looking for 0.7 or 0.9, that's less than a volt, when the switch is actually closed or on. And then it's only looking for 1.6 to 2.3 volts when the switch is off, so the computer knows what gear has been selected. So you can see that it's not going to take too much to throw this thing off and set a code. There's your fluid temp sensor. It is part of the main harness. As you can see here, if you look closely here, you'll see that there is just 2 wires coming in, so if we did have another harness or another sensor, that we could actually wire in our own. It's a thermistor type sensor, nothing unusual about it. Works like the ones we've always seen in the past. We added some heat to it, and as you can see, the more heat we added, the more the resistance actually dropped. The main harness that comes in from the case has to be separated from the solenoids, and it has what they call a cam-style lever lock. And you can see it's locked up there on the top. All you do is flip the handle up, as you see on the right, and that connector will come out real easy. Nothing else special to do there. To remove the valve body, you're going to find that there's 11 bolts. 7 of them are long and 4 are short. I didn't really bother to mark which ones the short ones would go to. If you're actually working on this valve body, you'll easily see where the 4 shorter bolts will go. I just wanted to mark out what bolts you have to take out altogether. Once we get the valve body off, and the first thing you're going to take off is right over there what they call the control solenoids plate. We're going to take that channel plate off first, and as soon as you do, you'll see 7 of these accumulators. Now these 7 accumulators and springs are actually accumulators to dampen the signal fluid from each of the pressure control solenoids. So they want to smooth that oil signal out before it actually gets to the control valves. All the springs and all the pistons are exactly the same size, so you don't have to worry about mixing them up. What I did like about this design was we've seen in the ZF units the accumulator is very similar to this, and they use a rubber ball on the bottom of them as a cushion. Those have a tendency to flatten out over time, and then we have some issues with shift concerns because of that. I don't see these springs wearing out anytime too soon. They're pretty hefty springs. There's one more large accumulator in the valve body, as you see here. This is basically going to be for forward clutch engagement. This particular clutch comes on as soon as you put it in drive. You also have the spring dimensions for that spring also. Okay, going back to the top of the valve body, the same area where you find the accumulators and springs, you will also find some check balls. The check ball size is the same as an old 350, except instead of steel, they're the same white nylon type check ball that we find in the ZF units. So in this top section, you'll find 3 small check balls there, because there's 10 altogether, 9 small ones and 1 large one. Now once we remove the solenoid body off of the valve body, as you can see on the bottom right, you'll have 1 more small check ball there, and that's where you'll find the large check ball. And if we flip the solenoid body over, which is the top of the main valve body that we're seeing here, that's where you'll find the other 5 small check balls. This should look pretty familiar to everyone. It's basically exactly like a 6L80, and that's the orientation of the snap ring opening, because we have a blind spline. As you can see, we have a blind spline at the top of this clutch pack here, and 180 degrees to the other side of the drum is we have a blind spot there. Now, I can understand how easily this can happen. I was actually throwing the clutches back in this drum, and I didn't have the snap ring in the right place. And I caught it. Someone was standing there with me and said, hey, you better double check that. But sure enough, I had the opening over here, and that definitely would not have worked. What I did notice something different about these pistons is this U-shape cut out here, and it lined up with the 2 holes here and this 1 blind spline. So when I started to check it out a little further, I actually loaded up the bottom set of clutches, and the top pressure plate for that has this opening, which also lined up with that U-shape. Now this is the apply plate for the upper clutch pack, and these legs on this apply plate go through the actual opening you see here in the pressure plate, and they align with the piston on the bottom. So basically the bottom piston applies to top clutches, the top piston applies to clutches at the bottom. Fluid level check. Nothing real high-tech here. The only problem is that we are going to need a scan tool to monitor the temperature that you see here. Also, there is no fill tube or dipstick. So there will be a standpipe used inside the pan to set the fluid level. Most important thing is that the temperature has to be correct. As you see here, it has to be correct, or we're going to be underfilled or overfilled. Obviously, we don't want oil coming out of the vent or foaming up, causing any kind of pump cavitation. There will be some models, I don't know exactly which ones yet, that will have fluid temp information right there in the driver's information center on the cluster itself. If not, you're going to need a capable scan tool to do this. We give you the step-by-step on how to set the fluid level. If you're doing this without a factory factory service tool to change the fluid, you can see here we have the overfill and the drain here, and then we have this plug on the side. This might not be too easy to get to, especially in a Corvette. So then we can go in and make some kind of a tool to go ahead and fill it up. And remember, only use the Dexron HP fluid. One of the things I do want to mention though is this plug works exactly like the plug on a boat. You have to pull this tab up first or you're not going to get that out of there very easily. So you might want to let your installers know so he's not struggling trying to pull this thing out, only to find that he just had to pull up on that little tab first. This is the service done with a factory service tool. Pretty easy here. We don't have to worry about filling it up to that fill plug hole. The tool would actually just adapt right there to the bottom of the pan, and it would fill it to the correct level right there. Here's your fluid capacities for the Corvettes, and there's a slight bit of a difference between that and the trucks and SUVs. Line pressure test, we actually showed you step by step right out of the factory manual as far as how they want you to do line pressure checks on this. Obviously we're going to have the vehicle at operating temperature and no codes and things like that. What I do want to clarify something here is most of the factory manuals you'll find will point to both of these taps and say they're both used for line pressure, which they can be. That is correct. But the one on the right is actually the 1, 2, 3, 4, 5 reverse brake clutch. Now the same kind of confusion happened with the RE5, RO5As found in the Nissans. We were using the right-hand side tap close to the bell housing for line pressure check, which is okay because that is the brake band, and that brake band is on in forward and reverse and for every gear except fourth. So even though there may be pressure to that band, in some gears it's not being used, but in fourth there will be no pressure there. So some confusion would happen if someone was looking at a chart thinking that was the for line tap or just for line pressure, and they had a fourth gear problem, they would think they're losing pressure in fourth when they would see the gauge drop out in fourth, only to find that that's what it's supposed to do. So the same thing here. If I wanted to do a stall test, I can use either one of these taps. But if I have a problem in 6th, 7th, and 8th, I'm not going to use the tap on the right to check my pressure. I'm having a problem in those gears because the gauge will drop back down to 0. Special thanks to Robert Bateman over at Seal Aftermarket Products for helping me compile all this information, especially working with me on getting these pictures. There's the rest of the procedure to check your line pressure. Now when you do check line pressure in this, you're going to have to get a scan tool because we're going to command the solenoid on and off to see if the solenoid is working correctly with the pressure. What you're going to find on the scan tool data, it's in kilopascals. So if your gauge does not have kilopascals on it, we give you this chart that you can compare the reading on the scan tool with the reading on your gauge to see if everything is working correctly. Well, that ends today's presentation, sponsored by Seal Aftermarket Products. If you have any questions, this would be a good time to text them in to me, and I would like to thank you all for attending.